Welcome back, space enthusiasts. Today we have an exciting and groundbreaking discovery to discuss. The James Webb Space Telescope has finally found what NASA has been searching for in the Kuiper Belt. The Kuiper Belt, a region beyond Neptune filled with icy bodies and dwarf planets, has long been a subject of interest for astronomers. And now, thanks to the advanced capabilities of the James Webb Telescope, we have new and fascinating insights. Stay tuned as we delve into these incredible findings and explore what they mean for our understanding of the solar system. The journey into the Kuiper Belt begins with its first known member, Pluto. Discovered initially as a planet, Pluto opened the gateway to this frosty frontier. It took astronomers nearly 60 years to start filling the void with more discoveries, revealing that Pluto was not alone in its icy orbit. The intrigue of the Kuiper Belt first peaked on November 2, 2015, when one of the most astonishing images of this distant world was captured. This snapshot was a groundbreaking moment in space photography. However, that record has since been shattered. Thanks to the advanced optics of the James Webb Space Telescope, we now have the clearest view ever of the Kuiper Belt, unveiling details never seen before. Named after Gerard Kuiper, a visionary mid-20th century scientist, the Kuiper Belt owes much of its discovery to his groundbreaking work. While Kuiper did not discover the belt himself, his research laid the groundwork for understanding this critical zone beyond Pluto. Once thought fascinating merely for its shape and position in our solar system, the Kuiper Belt now promises answers to some of the most profound questions about our cosmic neighborhood. It stands as a testament to human curiosity and our relentless pursuit of the unknown. In 1951, Gerard Kuiper published a seminal paper that sparked the imagination of astronomers worldwide. His study ventured beyond the known boundaries of our solar system, suggesting the existence of undiscovered objects beyond Pluto. Though Kuiper's speculations were broad, lacking details about the nature or arrangement of these objects, his ideas laid the groundwork for future explorations into what we now call the Kuiper Belt. Originally, Pluto was considered the crown jewel of this mysterious region. However, as our understanding deepened, it became clear that Neptune, not Pluto, marks the inner boundary of the Kuiper Belt. Neptune's mighty gravitational influence plays a crucial role in sculpting the belt's structure and the orbits of its objects. Despite some initial discrepancies between Kuiper's theories and later observations, his contributions remain foundational to our understanding of the outer solar system. His vision set the stage for a cosmic shift in how we perceive our planetary neighborhood. It was back in 1930 when Clyde Tombaugh made a groundbreaking discovery, identifying Pluto within this very belt. At that time, the outer solar system was largely a mystery, with most astronomers assuming it was a sparse region dominated by gas giants and devoid of other forms. Tombaugh's discovery challenged these assumptions, unveiling a zone rich with icy bodies beyond Neptune. This revelation gradually shifted the scientific consensus, binding Kuiper's theories with the tangible reality of a dynamic and icy outer solar system. Today, we recognize the Kuiper Belt not just as a distant point of interest, but as a vital part of our celestial home, holding clues to the formation of our solar system and possibly the origins of life itself. Once believed to be the outermost sentinel of our solar system, Neptune, the icy giant, marks the threshold to a realm teeming with celestial mysteries, the Kuiper Belt. Initially, scientists thought of Pluto as a lone planet, an outlier with its irregular tilted orbit. It wasn't until 1992, a full 62 years after Pluto's discovery, that the second object in the Kuiper Belt was identified, reshaping our understanding of the cosmos. This discovery was a turning point. It confirmed that Pluto was not an isolated entity, but part of a vast ensemble of objects in the outer solar system. As more Kuiper Belt objects, KBOs, came to light, the existence of the Kuiper Belt, a region beyond Neptune filled with an array of icy worlds, was irrefutably established. Pluto, once hailed as the ninth planet, holds a venerable place in the annals of astronomy. This title endured for many years, But as explorations expanded and more KBOs were found, some even larger than Pluto, the International Astronomical Union redefined the criteria for planethood in 2006. Pluto was reclassified as a dwarf planet, yet it remains a cornerstone of our solar system's history. Without Pluto's discovery, our curiosity might never have propelled us as deeply into the Kuiper Belt as we have ventured today. This unique region is now recognized not merely as a collection of icy bodies, but as a crucial extension of our solar system, offering insights into its origins and evolution. Our solar system is a dynamic and intricate tapestry, woven with the gravitational pull of the sun at its heart. Within this cosmic dance, the inner solar system is home to the 8 major planets, including Neptune. Beyond this familiar neighborhood lies the mysterious Kuiper Belt, stretching to the very edges of our solar system. This outer realm is starkly different from the bustling inner solar system. It's a silent expanse filled with icy objects like comets, asteroids, and dwarf planets. NASA experts believe the Kuiper Belt holds remnants from the dawn of the solar system some 4.6 billion years ago. Preserving conditions and materials from an era long past, the Kuiper Belt offers a unique window into the cosmic events that shaped our celestial home. Among its inhabitants are Pluto and its moons, alongside other dwarf planets such as Haumea, Makemake, and Eris. These frigid outposts are surrounded by a host of other icy entities, each with its own story to tell. Unlike the main asteroid belt, which lies between Mars and Jupiter and consists mostly of rocky bodies, the Kuiper Belt is a vast, distant, and icy realm. In comparison, the main asteroid belt is relatively sparse, filled with small to medium-sized rocky bodies. In contrast, the Kuiper Belt is expansive and far more remote, offering a profound glimpse into the building blocks of planet formation and the outer limits of our solar system's influence. Imagine a vast, shadowy expanse far beyond the familiar worlds of our solar system, a realm teeming with hidden mass. The Kuiper Belt, a distant frontier, holds 20 to 100 times more mass than the asteroid belt that lies between Mars and Jupiter. This vast difference in mass comes from both the sheer number of objects and their combined heft, making the belated discovery of the Kuiper Belt one of astronomy's greatest surprises. Despite its late recognition, the importance of the Kuiper Belt to our solar system cannot be overstated. It is a celestial haven, housing not just small icy objects, but also dwarf planets like Pluto, Haumea, Makemake, and Eris. Pluto, discovered in 1930 by Clyde Tombaugh, once held the title of the 9th planet. However, in 2006, the International Astronomical Union redefined what it means to be a planet, and Pluto was reclassified as a dwarf planet, measuring about 2,377 kilometers in diameter. Pluto's story and its path around the Sun, with other large dwarf planets in the Kuiper Belt, have sparked intense research and fascination. Yet, Pluto was just the beginning. Haumea was discovered in 2004 by a team led by Mike Brown. Its elongated shape, possibly due to its rapid spin, adds to the diverse tapestry of the Kuiper Belt. These discoveries and ongoing research underscore the Kuiper Belt's role as a critical zone for understanding the solar system's boundaries and the evolutionary processes of planetary bodies. Far from being just a collection of icy relics, the Kuiper Belt is a dynamic and essential chapter in the cosmic story of our solar system. Certainly. Here's a more dynamic rewrite of your script about the Kuiper Belt. Venture into the Kuiper Belt, a celestial treasure trove that extends far beyond the gaze of standard telescopes, where dwarf planets whisper secrets of the solar system's infancy. Among these enigmatic bodies, Haumea stretches 1,260 kilometers across, offering insights into the belt's diversity. Discovered by Mike Brown's team in 2005, Haumea's rapid rotation has shaped it into an elongated spectacle, enriching our understanding of celestial mechanics. Makemake, another gem found by Brown's team in 2005, spans about 1,430 kilometers. Lacking a substantial atmosphere, its brilliance comes from a reflective surface coated with methane, ethane, and tholins, making it one of the brightest objects in the Kuiper Belt. This shining dwarf planet adds to the colorful mosaic of our outer solar system. Eris, slightly smaller in size compared to Pluto but with greater mass, measures approximately 2,326 kilometers in diameter. Its discovery in 2005 played a crucial role in the astronomical community, prompting a redefinition of what constitutes a planet. Eris highlights the diversity and dynamic nature of the celestial bodies in the Kuiper Belt, informing us about their movements and interactions. These discoveries are pivotal. They not only expand our knowledge of the Kuiper Belt's composition and its evolutionary narrative, but also clarify its role in our solar system's history. Without these dwarf planets, our map of the cosmos would be far less complete. Often confused with the distant Oort cloud, the Kuiper Belt is distinctly different. It hosts a myriad of objects and is believed to be the birthplace of short-period comets. This distinction is crucial for understanding the migration patterns of comets as they journey toward the inner solar system. Imagine two vast, frigid realms on the outskirts of our solar system, the Kuiper Belt and the Oort cloud. While both are icy treasure troves, they are markedly different in structure and location. The Kuiper Belt, a ring of icy bodies, orbits relatively close to us, within the confines of our solar neighborhood. It is here that short-period comets, those with quicker orbital turns around the Sun, originate. These celestial wanderers are like cosmic messengers, carrying secrets from the early days of our solar system. Farther out lies the mysterious Oort cloud, an immense spherical shell enveloping our solar system at distances ranging from about 2,000 to a staggering 200,000 astronomical units from the Sun. This distant cloud is composed of countless icy objects, often described as dirty snowballs. It is the birthplace of long-period comets, those with long-stretched orbits that plunge them into the warmer inner solar system, where they blaze up, driven by solar radiation, to display spectacular comas and tails. Both the Kuiper Belt and the Oort cloud serve as reservoirs for comets, yet they are distinct not only in their composition and structure, but also in their contributions to our understanding of the solar system's past. Comets from these regions are frozen time capsules, containing primordial material from which our solar system was formed. As they approach the Sun, their icy cores sublimate, releasing gas and dust that form the glowing coma and tail that make comets so enchanting to observe. The differences between these two regions can be subtle yet profound, offering scientists invaluable clues about the processes that shaped our cosmic environment. While it's easy to blur the lines between these icy bodies, each plays a critical role in the cosmic dance of our solar system. Despite the sparse material left in the Kuiper Belt, what remains is incredibly telling. These fragments are not mere remnants, they are the archaeological artifacts of the cosmos, pieces of a puzzle that was once much grander. According to the Nice model, a theory of solar system evolution, these shards are not randomly dispersed, but are the result of dramatic gravitational influences that sculpted our solar system's structure long ago. Imagine the outer solar system as a cosmic dance floor, where the four giant planets, Jupiter, Saturn, Uranus, and Neptune, have not always glided in their current graceful circular orbits. Instead, according to the intriguing Nice model, these behemoths once partook in a dramatic ballet of orbital evolution, their paths dramatically morphing under each other's gravitational influence. Originally, it was believed that the Kuiper Belt contained a mass 7 to 10 times that of Earth. However, the Nice model paints a scenario of significant upheaval, suggesting that much of this material was lost to the void. As these giant planets jostled and shifted, their gravitational tugs flung material from the Kuiper Belt far and wide. Some of it was ejected completely from the solar system, while other parts were dispersed to distant corners or drawn inward. This gravitational reshuffling has left the Kuiper Belt much thinner than it once was, a shadow of its former self, slowly eroding over eons. The interactions within the belt are violent and frequent. Collisions between icy bodies shatter them into smaller fragments. These fragments can either coalesce into comets, embark on journeys towards the sun, or continue to break down further. The remnants of these cosmic collisions, dust and smaller debris, are often caught by the solar wind, swept away in a silent exodus from the solar system. This continual process of creation and destruction in the Kuiper Belt provides a fascinating glimpse into the dynamic and ever-changing nature of our solar system. The Kuiper Belt, a distant belt of celestial objects orbiting our sun, might seem less massive than we initially thought. Scientists now estimate it holds no more than 10% of Earth's mass. Yet, this remote region of space is anything but insignificant. Surprisingly, many objects within the Kuiper Belt boast their own moons. These moons are smaller bodies that orbit a larger host, not unlike the familiar moons of our planets, illustrating that such celestial relationships aren't exclusive to the planet-moon systems we're used to. Moreover, some of these Kuiper Belt objects, KBOs, form binary systems where two roughly equal masses orbit around a common center of gravity, their barycenter, revealing the intricate dance of gravity even at the edges of our solar system. Some binary pairs even touch, creating what are known as contact binaries, which resemble a peanut shape. This unique formation results from the gravitational forces pulling them together, a phenomenon that wasn't fully understood until relatively recently. Deciphering these distant mysteries required bold missions and technological innovation. Pioneer 10, launched by NASA on March 2, 1972, was a trailblazer in this quest. As the first spacecraft to fly beyond the asteroid belt and directly explore Jupiter, Pioneer 10 set the stage for our journey to the outer reaches of the solar system, bringing us closer to understanding the complex dynamics of the Kuiper Belt. Pioneer 10, equipped with cutting-edge scientific instruments, embarked on a groundbreaking journey that would forever change our understanding of the solar system. As the first spacecraft to traverse the asteroid belt, Pioneer 10 blazed a trail toward Jupiter, delving into the mysteries of its vast atmosphere, powerful magnetic field, and intense radiation belts. In 1983, Pioneer 10 achieved another milestone. It became the first spacecraft to enter the enigmatic Kuiper Belt. Although its primary mission was to study Jupiter, and at the time of its launch Pluto was the only known icy world, Pioneer 10's trajectory allowed it to venture beyond the gas giant and into the distant reaches of our solar system. This daring explorer sent back invaluable data from Jupiter, enhancing our knowledge and whetting our appetite for further exploration. Its extended mission and longevity enabled it to travel just beyond the Kuiper Belt, offering us a tantalizing glimpse into the outermost regions of our celestial neighborhood. Pioneer 10's legacy paved the way for subsequent missions to probe deeper into space. Voyages like Voyager 2 and Cassini followed, each adding layers of insight into the outer solar system. Notably, Voyager 2's remarkable journey to Neptune's moon Triton continued the legacy of interplanetary exploration ignited by Pioneer 10. In 1989, Voyager 2's historic encounter with Neptune's moon Triton and Cassini's detailed study of Saturn's moon Phoebe in 2004 provided unprecedented insights into these distant celestial bodies. Scientists believe that some of these moons might have originated in the Kuiper Belt, swept up by the massive gravitational pull of their host planets. This fascinating theory, once obscure, underscores just how dynamic our solar system is. The journey into these remote regions was just beginning. A landmark moment came in 2015 when the New Horizons probe whizzed past Pluto, capturing the world's imagination. During its groundbreaking mission, New Horizons also targeted a lesser-known object in the Kuiper Belt, 1994 JR1. Snapping pictures from 170 million miles away, this small 90-meter-wide body revealed critical details about the composition and characteristics of Kuiper Belt objects. Meanwhile, the Hubble Space Telescope was making its own waves. In 2014, it identified 3 Kuiper Belt objects as potential flyby targets for New Horizons' journey to Pluto. It even discovered 2 icy, remote worlds on the outer edge of our solar system. These findings, captured in images from June 24th of the same year, prompted NASA to expand its hunt for more Kuiper Belt objects. Welcome to Blasovia Science TV, where we take you on an exhilarating journey through the cosmos and unravel the mysteries of science. We are excited to offer you the opportunity to become a valued member of our ever-growing community of cosmic enthusiasts and knowledge seekers. Exclusive access to cosmic content. As a member of Blasovia Science TV, you will gain exclusive access to a treasure trove of cosmic content, including documentaries, interviews with leading scientists, space missions updates, and awe-inspiring visualizations of the universe. Live Q&A sessions with experts. Your membership will grant you the chance to participate in live Q&A sessions with renowned scientists, astronomers, and space explorers. Get your burning questions answered by those who push the boundaries of human knowledge. Embark on a journey that spans the cosmos, and join us in unraveling the secrets of the universe. Become a Blasovia Science TV member today, and together, we will reach for the stars. Thanks for watching. Subscribe, like, and share. Don't forget to leave your comments.